All right. Hello, everyone. For those who I haven't greeted before, can you hear me well from the back? Okay, more or less. A little louder.
Yeah, louder.
Okay, we'll try. Uh, Today, well, first of all, it's nice to see some familiar faces here, and some of you I have met before. And for those who don't know me yet, I am Wagner and I'm the TMS Biz product manager. The TMS Biz is a product line that provides products for and frameworks for server-side, non-visual stuff. And in these 2 days, I give 5 sessions, and I try to bring you with those 5 sessions to bring an overview of main features of this TMS B spec. And also as a side job for me, I'm becoming a TMS training days speaker as a regular. So I believe some of you were present before in one of these days. And nice to meet you again here. And unfortunately, we didn't have events in the last years because of all the pandemics, but now we are back, and it's a pleasure to be here. So, this session, I will talk about TMS Sparkle, which is the basis of our HTTP server technology, all right? In all these 5 sessions, mostly I'll talk about server-side software, application server. So it will be a multi-tier application technologies. And this is the base one because most of the applications are based on HTTP. And in this session, my intention is to just talk about the basics so you can understand how HTTP works and how TMS Sparkle fits in this, and especially about deployment. And first question thus, which of you are not familiar with HTTP? All right. And which of you doesn't know about TMS Sparkle, which is our HTTP framework? Okay. So I think you have most people here know about it. So I'll try to make it fast here, just to catch up for those who are not used to it. So HTTP, how can I say it in a very short way? It's a protocol that you send text over the network, so to speak. So it's a way to communicate via network, but HTTP is the content of the message. So it's a protocol where we send text message and receive text message, okay? And those text messages are preformatted. So basically, in a very summarized way, that's what HTTP is. So the client sends a request to the server with text, all right? This text is structured that way. When you have a URL that we are all used to in the browser, you have an URL, HTTP / and the address, and that green part there is the URL. And you have the HTTP method, which is the part in red, which can be get or post or put or delete and things like that, okay? And the request and the response, you have in the text, you have headers, which are a kind of metadata of the message. When you have those many lines with the green name is the header names like date, content type, content length, and the black part is the value of the header. So this is a kind of metadata of HTTP. What's the size of the message? What is the type of the content that I have? Is it a text? Is it a PDF? Or is it a JSON? So metadata, and specifically in the response, we have the 200 number is the response code, all right? When the server responds, there's a status code, which means OK or error or things like that. And finally, at the end of the message, you have the content body, which is the actual PDF content or the text content or the HTML content or the PDF content. Both client and server can send or receive that message body. Okay? So these are more examples. This is the example of the request URL. We are all used to it when we use internet browser. We have the scheme, HTTP or HTTPS, which is the secure encrypted version of HTTP. We have the domain, which is the server, that host part, which is the machine, the server we are trying to reach. Okay, this is important later for the deployment. I will try to focus here on the deployment of the servers. So we have to tell which is the computer that is running the server. All right. When we are going to deploy our server, we are going to install the server in a computer, and all the clients will reach that computer to get responses. And that host is the address of the computer. And after the host and the port, we have the rest of the URL, which is the path, which is /forum/questions, or is the index.html. You have that kind of, it's like a file path of the document of the information that you want to have. Okay? You still need that I talk louder? It's okay?
Was this a valid URL? Was this a valid?
Sorry?
Is user info in front?
User info?
Yeah.
This is just an old basic authentication scheme. And it's
nowadays not.
It's not used these days. Okay?
But
I should remove this. What?
It's valid.
Yeah, it's valid.
Okay.
But only for basic authentication. You know, when in the old sites, when you try to reach a browser, it opens username and password, that very old dialogue in browsers.
Okay.
So that's for it. Today we're not using it anymore. Okay. And then here comes TMS Sparkle. What's TMS Sparkle? It's a core framework in TMS BIS product set that provides you with tools for you to implement this HTTP communication. All right. Usually, you should not worry about this low-level communication. Even in the HTTP part. In the next sessions, we'll talk about how Xdata and how other frameworks we have will help you to code without worrying about all this low-level stuff. But first, it's good to know about how it works, the protocol, and also how TMS Sparkle works, because it's like learning a magic trick, right? And you see the magic, and you kind of gets lost. But when you learn the magic trick behind it, it's like, oh, I'm comfortable now. I know what's going on here. So that's more the same with TMS Sparkle here. We have the session. You learn about how to configure, understand the HTTP stuff, how to deploy your server. But once you have learned that and you have set up this in your application, you could forget about it and focus on your business code. Okay? But still, we are here to learn the basics. So TMS Sparkle is the framework for this HTTP communication. Why TMS Sparkle exists? Well, first, it's a few features. It's multi-platform, cross-platform. It's all under TMS control, because in the next slide we have a few motivations. You might ask, isn't there anything ready in Delphi for HTTP? Yes, we have the good old INDI components, right? Which are components to both client and server communication. And recently we have Web Broker, we have other frameworks, open source frameworks. But the motivations here, when you developed TMS Sparkle in 2013, I guess, I don't remember exactly, was that we were envision what we have now, the TMS BIS, and we were envision that we have a full ecosystem of tools, and we do have. And we need to rely on the basics, right? For example, if you relied on the indie components that we support, but if we only had that option, we'll get stuck and we'll depend on a third party for that basic core of our architecture, right? And with the TMS Sparkle, the idea is that we have full control to make it, to fix bugs as fast as we can, to do the changes that we need in case we need more optimization, in case we need more cross-platform support and things like that. So the idea is that we could not rely on third parties, and Delphi was becoming cross-platform at that time. We really need to make sure that we will support all the platforms with full control, so to speak. And for you as a user, the advantage is that you have our support on that framework, and we are making sure that it works great. Okay. This is our use cases for TMS Sparkle, which is built an HTTP server and clients, and so I explained that it's the core of all of the solutions we have for multi-tier applications. Any questions so far? Yes.
Can we use just core TMS Sparkle as web server without Xdata?
Yes.
Yeah.
Yes. That's the point, that actually that it's a different name. It actually causes confusion to users because why it's TMS Xdata and TMS Sparkle is different. Exactly because of that, right? Actually, I will explain here that TMS Xdata is just a plugin for Sparkle. I will explain that here. This is the Sparkle architecture. I presented this in 2019, but I repeat it again. You have the computer. We're talking about server, all right? HTTP server here. We have the computer and the OS where your server runs. That computer is running an application, an executable, which is the host application, all right? It's the Delphi executable that you create, that you are running in your computer. And then inside the application, you have the dispatcher, the middle, and the model. So the computer can be Linux, Windows, Android, or any other computer or OS you are running your server. And the host application, you can use many types of Delphi applications. So you can have your Sparkle server running in an FMX application on Windows. Or you can have a VCL application on Windows. Or you can have it running in a console application on Linux. All right, so you have all these options here for the host application. And then the dispatcher, I'll explain it better later. We have different kinds of dispatcher, which are ways that HTTP is processed internally. And finally, we have middleware and the models, which are the specific processing of HTTP. It's like your business code, so to speak. We have different models like static files, RemoteDB, Xdata, Echo. RemoteDB, Xdata, Echo are TMS BIS frameworks, products, and in a sense, they are Sparkle models, as we explained here. All right, everything is a Sparkle, and Xdata is just a model. Echo is a model. RemoteDB is a model of that you plug into Sparkle. This is another way to see it. So you have the internet and you have HTTP communication between the client and your server. And the biggest box there is your host application. It's your Windows service, it's your VCL application, it's your console application, all right? So the HTTP is coming and it's entering your host application, and inside your application, you have the dispatcher and the server model. This separation is interesting to learn. As I say, you'll not deal with it daily, but it's interesting to learn the deployment and the structure of your Sparkle application. So the dispatcher is the concept where your HTTP comes and it translates the HTTP low level to an abstract class in Sparkle. Okay? It's the context. So you have many different dispatchers, many different ways that Sparkle does its job that you don't care about. And in the end, the dispatcher gives you classes with the information about HTTP. And those classes are then passed to the server model. So you're basically going to code in the server model layer, and there you are receiving abstract HTTP information. That is the same regardless of the dispatcher you are using. That's the idea of the dispatcher, okay? To abstract and translate and make it high level for you. And then we have the concept of the middleware, which is a filter for HTTP requests. It's a way, you will see that it's a way to make your server structured, working with a kind of plugin that you can plug middleware into your application. Each middleware will filter out the HTTP requests until it gets to your business logic, so that you can process your HTTP, for example, like compress is one example of the middleware to illustrate, right? So you have your application working, and suddenly you say, oh, my responses are too big, the JSON is too big, and I need the server to send a compressed message to the client to reduce the size. So you don't have to work that on your business code, on your server model. You just add a middleware, the compressed middleware, which is this kind of filter. The message comes, your model will respond the same way, but the middleware will, in the middle of this transmission, will compress the response. Okay? So that's the intention of the middleware, to be a kind of plugin. So you have a few built-in plugins in the framework, which is compress. For example, logging. You don't have to worry about log your requests in your business logic, in your server model. You just plug the logging middleware, and you have your requests being logged somewhere, but it's in a different place of your application. Some other examples are the CORS middleware, to make it available for web core applications. The JSON Web Token middleware, that I will talk about in details in the session about authentication and authorization. We have a session specific to learn how to authenticate and protect your Xdate application. We have the tenant middleware, that you have a specific questions for that as well, which is a middleware to help you build multi-tenant applications. And we have the generic middleware, which is just something that you add custom code. And we have the forward middleware, which is a new one. Forward and login is a new one compared to for those who were in 2019. Are two new middlewares. The forward middleware is a middleware to translate information when you have your server behind reverse proxy. Okay, I will talk about this today in the deployment part. So when you have your deployment with a server in the front, the forward middleware will help you out. I can give you details later about it if there is time. Also interesting here, the middleware, the order of the middleware is important. Okay, because for example, if you have this order here in your application, if a request comes and you reach, for example, JSON Web Token, all right? The JSON Web Token is about authentication. So the JSON Web Token middleware can reject the request if it's not allowed, for example. So if you have the middleware in this order, that request will be logged because the login middleware is before the JSON Web Token middleware. Okay? So you have your request logged, and then you have your request rejected and responded. So in this order, the three last middleware will not be reached because the request was rejected by JSWeb token. Okay. So I'm telling this because in practice, when you are building your application, sometimes you might ask, well, my requests are not being logged if the user is not authenticated. That's because you put your login middleware after the JSWeb token authentication, for example. Okay. So this is the suggested order for the middleware. In case you want to have a reference when you are developing, it doesn't fit all cases, but this is the more general case. Is the suggestion first the forward, then the login, compress. Okay, when you might not need all the middleware, but when you need, try to put them in this order. If you don't know the orders, this is the suggested order.
In case of all implementation.
I'm sorry?
In case of all implementation, we have several middlewares. If is it okay if my own implementation on the bottom of the list? Yeah, not on top of. Like
what the question? What's the question?
If I have own middleware implementation,
okay,
is it best practice to put on the bottom of the list?
The question is, if you have your own middleware implementation, in which position should I put? Only you can answer.
Up to me, yeah.
Yeah, because it depends on what your middleware is doing, right? So unfortunately, that's why I put the generic in the last one. That's the generic where you put custom code. So it depends. It really depends that you have to think, is this middleware, do I have to have login information already or things like that? Okay?
Yeah, okay.
And you see that another new feature here. Let me see if it's time. Yeah. It's the context. It's a new concept that we introduced in TMS Sparkle, which is the context of the request. And this is important in the middleware stuff as well. What is this? It's something that it's information that you add to your request. For each client request, you have this information. Remember that we are talking about a server, so you can have many clients requesting, sending requests at the same time. So the context of the server code is that you are always running code that is processing a client request, right? You might have 10 requests running in the server, and your code is always answering one request. And this is the context of the request. It has meta information like the URL, the path that is being requested, what the client is sending to you. And then you have this new concept that you can add your custom information to the context. In this example here, I'm setting tenant ID to 5. Think of it as a global variable, of your request. Okay? And you can set objects and interfaces. Why is this? Because sometimes you have to have a custom middleware, for example. The tenant is the best example. You have a request coming, and you want to know what is this user, or which is its company. You have to know some kind of information about this client to identify him, for example. And your business logic will depend on it. I mean, I have to know the tenants, the company. So let's say the company. I have to know the company of this customer. And sometimes the information is not in the database. All right? Maybe you want to separate your companies by URL, for example. So you put a middleware where you put your custom code that you find the tenant for this customer. And then you set this information in the context, in the middleware, so your code later can read that information and do any process it needs. Is it clear? Any questions about this? Because this is a very interesting concept here. Okay? So the middleware, this is common, this context is very common to be set in the middleware, in a custom middleware. All right? And sometimes, for example, the tenant middleware does that. It automatically, we'll see in the session, it automatically sets the tenant of the request. All right? And later in your code, you just read that. What's the tenant? You read that with the context, all right? And you might have your custom code that also sets any information that you want from the context. And the order is important because you might have middleware that depends on the context information that you might have previously set in a previous middleware. So that's important also, the order. Okay? Sometimes I feel like I'm giving too much information, so just stop and ask if you need to. So information about the dispatchers. Remember that we talked about the dispatchers here. Web broker here, right? The dispatcher is the concept that processes the low-level HTTP and gives you everything in an abstract way. So you have currently 4 dispatchers in Sparkle. Yes?
The tenant ID. Could I use the same ID more than one? Or must I have for each question to the server a new tenant ID?
I'm sorry. Can you repeat the question?
Yes. The server is, or the middleware is connecting between my client and my server. So the tenant ID I use, is it possible to use it more, the same ID, more than one time, or must I do it for each request to the server a new ID?
No, the tenant ID is not for creating an ID. It's to identify which is the tenant ID of the client.
Okay. So I can use it more than once to identify the same connection between one special client and the server.
Yeah, we have a session about this, specifically about tenant, multi-tenant application, but it's to identify the tenant. But don't worry, that small middleware, tenant middleware will become a whole new session tomorrow. All right? So, for dispatchers, the http.sys, which is specifically for Windows, Indy, so you can still use Indy for Linux and Android. We have customers running Sparkle servers on Android tablets. And you can have web broker, the regular web broker that's mostly used for Apache model. And we have an in-process dispatcher for local applications. Is mostly used for tests and debugging. You can run, for example, unit testing using an in-process, so you can do requests and responses without having to worry about HTTP. It's just in-memory processing. Okay. This is, as I said, this is something that you don't have to worry in your daily use. Sparkle handles this. It uses Indy and uses HTTP-sys. It doesn't matter. It gets the information that about HTTP request and response and gives you the abstract classes to work with. Okay, this is the platform supported. So mostly if you are using Windows, http.sys, that's the most recommended way. If you are using Linux, web broker or Indy, and for testing and debugging in process. Yes?
Platforms means platforms for server or for client. Because I have a feature with exception handling. If I have server based on http.sys running on Windows, I can get exact exception message what happens. But on Android, I got something strange.
You do have that problem.
Yeah.
Well, you have to say your specific code, because the idea here is your code will be the same regardless the dispatcher and regardless the...
Let's say if there is no connection to server, I get connection on Windows. There is no connection. But on Android, I have something jne.something and long exception message. I don't know why, but yeah. And second problem was that if I use raise exception and then number like 400, it's a big problem on Android. It's somehow less this. I have to use this raise exception create without number, some default value.
The raise exception, it's
Yeah.
okay.
If I use some number 401, it's somehow move my
It's okay. It's a specific. We can talk about in the breaks.
basic.
Yeah, but it should be. The question was that issues with different behavior with Android, your report different behavior with Android and Windows, for example, but it should not be, especially because.
The question was the exception handling on different platforms. Is it for us as user the same?
The same. That's why it should be the same. So this is a specific issue. This should be all the same.
Okay.
Okay. That's the dispatcher here. As I said, you should not worry about this on your daily development. This is for you to understand and learn and set up a deployment application. But once you are coding in your daily business, you should not be worried about this. I even showed my example here is that exactly that you have different host applications here, but your code is the same. That's the purpose of my presentation here. I hope it's fine. So it should be all the same. Okay. Okay, a little bit about deployment. We have this suggestions for deployment. We can talk about Windows and Linux deployment here all day. The thing here is that servers, Linux is usually most recommended for servers. But here, I suggest Windows is also a great contender, especially because of Delphi. All right, Linux is a new platform to Delphi compared to Windows, and in our internal tests, we find more bugs related to Linux than Windows, which is expected because Windows is supported by Delphi since forever. So it's very stable. The code is very reliable and faster compared to Linux. And since we all come from Windows, we are all Delphi developers. I think we are all most familiar with Windows. And it's easier to, unless you are a Linux expert, it's easier to set up, to work and maintain and solve situations there, right? And http.sys is a great framework for Windows. So it's the recommended way. And if you need Linux, you can use WebBroker as a patch model or Indy. But you might say, well, is Indy reliable for production code, for heavy code, for millions of requests? Sometimes it's not. But then there are suggestions that you can use reverse proxies for that. 15, 20 years ago, that was not the case, but today it's very, there are many reliable and robust open source and free options. So that's one of the good things about Delphi. You can code with Pascal in our old Windows way, but you don't have to have your whole solution in Delphi. You can code your business in Delphi, and then you have a reverse proxy in front of it, for example. All right? So you have many options here. Is that a server that you be public to your application, to your clients, and your Xdata server is behind it. So it's a way to doing load balance as well. So you can have, for example, Nginx or traffic proxy in front, and you have 1 or 2 or 3 or 4 Xdata servers in front of it. Okay? So that's one option for Linux, for example. You can have 1, 2, 3, 4 Indy-based Xdata Sparkle servers. Sparkle, not Xdata. Sparkle servers, and you have one of these in front of them. So you minimize the issues you might have with Linux, like errors or speed, okay, or memory issues. Or you can use cloud services as well, like AWS application load balancing. We cannot cover this here, but that's information and options you have, okay? And you can have scalability. As I said, you can have many servers, many of your servers behind this if there is time, actually, over the 5 sessions, I will try to illustrate everything we are learning here and seeing here with a real-world example, which is a SaaS service that we run in Brazil that I have close contact with them. I strongly participate in the development. So it's something that I have, I can make these technical decisions for this platform. It's called Nuvem Fiscal. And I have the freedom to show information for you here. So I can show source code, I can show the deployment setup. So I think it will be interesting that I show you guys how a real world application API built with Xdata and Sparkle is working, right? And here's the setup. Let me give you a context before. This is what we are talking about. Okay. This is an API for developers. The customers of this solution are developers. And this solution is an API, a public API, paid public API, to communicate with Brazilian government, to create for invoices and taxes purposes. So you have lots of legal electronic documents in Brazil that companies have to generate and communicate with Brazilian government for that. And this API is a helper for all software developers in Brazil that needs to handle taxes, which is a lot of a big market, of course. Okay, so this is what I'm talking about. So you have this. This is the website for selling, and there are. You have some plans here, paid plans. It's a SaaS, software as a service, okay, as an API. And I will mention the solution over the sessions to give you examples about how it's implemented, how it's work is inside, okay? And this slide here is one of them. This is the basic setup. This application is running on Amazon Web Services, and this is the basic setup of the servers that it runs. Okay, so you have it's very small here, but you have the proxy. Okay, you have the proxy machine, which is running a traffic proxy. The software is a Linux machine running a traffic server that receives the public connection. So this is the machine from AWS that is open to public. Okay, port 80 or port 443 for the HTTP connections. And then you have the API, which is a Windows machine, which runs it's an Xdata server. Okay, this can be scalable. This can be multiplied if it requires more. The English word, more requests, if the volume of the requests are higher. Okay, this machine is not open to public. It only accepts connection. It's configured to only accept connection from the proxy machine. All right, so it's protected. So it's HTTPCs and Windows. That's another reason as a consulting, I suggest for customers to use Windows, because one major question is how Windows is more expensive in cloud services, sometimes 3 or 5 more expensive. But depending on your setup, the cost is not that much compared to other things that you can measure, like familiarity with Windows and things like that. Because the heavy work here, to finish, and you have, in this case, you have a Postgres database machine also running on Linux. All right. So the thing is, the heavy work is being done by the proxy and the Postgres database. Both are Linux. All right. So if I need more database power, if I need some request power, that's not the case, I manage the Linux machines. And only my business code is running on Windows. Okay? And usually in real world, that's the machine that needs less resources, because also Sparkle and Xdata are lightweight. Okay? So it's not that you are running a Windows 3 or 5 Windows machines with 8 gigabytes in memory. So you have many Linux machines running, a few of them, and the Windows might be small. Okay? So this is the architecture. Okay, let me give you some code here. When I mentioned about the dispatchers, here is our Sparkle application. I will run this first one. Okay, this is our host application, which is a VCL application. Okay, the server is running at this address here. All right, localhost /TMS/hello. Okay, how it's implemented? We have in the VCL server, we have this model where we have this Sparkle generic server, which is the model, remember? And all it has is this code here, which, as I mentioned, is the abstract information about HTTP. So you have, that's why I talked about HTTP before. In HTTP, you have the status code. You have to set the response for the server. So a request is coming, and I'm answering, okay, respond with status code 200, and set a header value, tell the client that this response will be a text message, and the actual content of the response will be hello world. Okay? Any questions here? Is it fine? Great. And as I said, this is the model. It doesn't matter if the dispatcher here is Indy or HTTPCs or in process or Apache model. The code is the same. Okay? And you see that I put this on purpose on a different data model. So I have the Sparkle generic server on a separate data model, and this is my business code. Okay? And in my VCL server, this is the application, VCL server, we have that data model that I showed you right before, and we just have the main form. Okay? And in the main form, we have the dispatcher component. So the dispatcher is responsible for processing the HTTP and then sending to that other component that processes the response. And all you need to do here is exactly say that component, the model, the dispatcher I'm using is the HTTP sys. Okay? Then I start the server and it's running. Okay here? Any questions? Why I want to show you this? Because I see many users struggle with deployment. So this is one suggestion for deployment of Sparkle applications. Because now you might think, okay, this is a VCL application, but in real world, I want to have a Windows service applications, for example. So I will install my Sparkle server as a Windows service. You can do it. So I can have a second host application that runs the same Sparkle server. Okay? So this second one is a Windows service application. This is just regular Delphi application. I just went to Delphi here and said File, New. File, New, Windows Service. Okay, so that's the main form there is what Delphi generated for me. And we have this. So this data model here, it was generated by that Delphi wizard. And all I did was to put the same dispatcher components. And in a few events, on service start, I just use that same code that I use in the VCL application. Set the dispatcher and start. And in service stop, stop the server. Okay? So I can compile this and install it as a Windows service. Note that that's the main point I want to show you here. Both VCL and Windows Service share the same, use the same unit, that same hello server container, right? Just to recall you, both are using the same unit here. It's a shared unit, okay? But one is a VCL application and the other is a Windows Service application. And I can have a console application that does the same thing. It's compiling for Linux. So the same thing. Now it's the console application that is answering. Okay. And again, the structure is the same. If I look at the console application here, there is a method run server. Okay, in this case I'm using Indy. Okay. So now instead of HTTPC's dispatcher, I'm using Indy dispatcher here, but the idea is the same. Just create the Indy dispatcher here and use that same model and set the dispatcher. All right? So I have a VCL application, a Windows Service application, a console application, VCL application using HTTPC's dispatcher, Windows Service application using HTTP dispatcher, a console application using Indy dispatcher. That means that I can compile this application for both Windows and Linux. All the three of them, in the end, are just using the same unit that provides this response. Okay, so as I said, this is even a suggestion for you to deploy. I'll get to you. And the fourth one is this Apache model. Okay, you have access to this code later. So the fourth example is an Apache model. So the idea here is to show you that you can have different platforms supported, different host applications, console, Apache model, Windows Service, and by having different host applications, you can target different OS, Windows and Linux and whatever. But once you set this up, you don't have to care about these applications here. You're focused on this one, on your model, and you can reuse that model in all the applications. Another good point here is that, for example, we have customers using Apache model to deploy to Linux via Apache model. It's a nightmare to debug or check what's going on with Apache model because you cannot debug and things like that. But this is the suggestion I give to customers. Use a console server there and run it on Linux as a console server for your debugging, for your testing, for anything that you need. And just use the Apache server as a final test to see if there is something a little bit different and to deploy it. And it's possible here because, or you can even develop in the VCL Windows application here, most of the code, then run on console, on Linux, to check for Linux specific stuff, and then deploy as Apache model, but you're not going to debug an Apache model. So that's the suggestion here for the setup and a way for you to understand the structure. And as I said, once you have this set up, forget about it, at least until you deploy, and just code your user
I
code.
probably got the answer. My question was, what if I want, maybe stupid example, but if I have 100 tables and I want to implement query, so I need to build
You want to implement what?
queries. For every table, I want own path, and I have somehow to loop every table and add endpoint for dispatch. Is it possible in code? Because so far we make endpoint in X data, so from class. If I have 100 tables, I have to add 100 procedures to there. But probably this is the right place there to make my logic.
You want to. Oh, sorry. You want to break your application into smaller ones. You're serving smaller ones. That's the question.
No. I want. It's just example, but is there some solution for add endpoint in code, not from class notation or somehow from class, but in code, like just in one sentence. Please add this endpoint named like table name, and here is my code. And if I got this request, please return like something. Probably in that place, it's best procedure to handle this logic.
Yeah.
I don't need X data. It's maybe not so clear.
I apologize. Sometimes I have a hard time understanding the questions, especially because of my English. But
sorry for my English, but yeah.
To run direct queries on the table without using Slack.
Main question is about how to add endpoint for X data, not for.
okay, we have a session about X data.
Yeah.
But you are an X data user.
Yeah.
So you know how to do it.
Do you know probably Mika? He's
Yeah?
a big one. Yeah. Yeah.
Okay, we have an X.
Yeah.
Let me give you an introduction to the next one. This is, as I said, you have the dispatcher, and here is the code that you are going to work on, right? Request and response. So, right, as a small introduction to the next session, to the session of tomorrow about X data. Now we are going to code our application. What we have to do, in theory, we have to check here what is the URL that the client is requesting. Okay, you have to check this. What is this? Is this /customers, /orders, / do something, or / whatever? We have to check this. In theory, you have to check all the URLs, and you have to respond accordingly. I mean, is this /customer? All right, then do a query in the database and respond with a list of customers. Is this a /order? Then do the same. Is this a /create order? Okay, then what's the information that the client is sending to me? Is the order number, is the value products, etc. Read that, process that, do something in the database and answer that. So that's what you, in theory, should do here from now on. It's complicated. That's exactly what Xdata is for. Xdata is, as I said, Xdata is just a Sparkle model. It's something that you put here at this time, this position of your application, that will do that for you, that will give you high-level methods and procedures to make this easier for you. We'll see how it's done tomorrow, but it's like you have much higher level way to organize this in a very easy way. So Xdata parses this content, the parameters that the client is sending, what information it's sending, an easy way to respond, an easy way to go to the database. So that's exactly what is Xdata. Sparkle is about this, and Xdata about all this, and Xdata is this little piece, which is your whole application of processing and responding the request as you wish. Okay?
Can you show how to implement calls? Is it a very simple process?
Yes. Course, actually course,
How to handle it?
yeah, we saw about the Middleware, right? And the Middleware is part of your application, so we have this your Sparkle model here, and you have managed Middleware lists, and then you have all the options that I mentioned in there. So which middleware you want to add? As I said, I want to compress my response, and I want to add course. Oh, sorry. So again, the order is important. So I have this, I added compress, generic, and coarse middleware. All right. So my request will go through and come back, and the response will be compressed. And now with coarse, it will be added automatically. So each middleware has specific properties. Okay. And the generic one has an event that you can ask custom code. Remember that I told you, you have code in your model and you have code in your middleware to filter your requests.
This, on the bottom code would be the generic code in this case. Your hello world would be
This one?
this one.
Yeah, this
The generic, for example.
could be, but it could be. But remember that the idea of the middleware is a filter. So
When does this code be executed, the hello world? After the generic or before?
after all the middleware. No, this is the model request. The model. The request goes to all the middleware and then go to the model.
And I only have one model.
You can have many models if you want, but usually for Xdata is a model.
Okay.
So you have Xdata and you have the middleware, the Xdata middleware. All right? We are out of time. Sorry about that. I'll be around. We'll have formal sessions for discussion, but for now we are out of time. And thanks a lot for being here.
All right, thanks, Wagner, for your session. So we are lunchtime now. Lunch is served on floor number 2. So it should be ready as we all arrive downstairs. And so after the lunch, which is our lunchtime, there are again the option between 2 sessions, either the room 2 on the 2nd floor or here upstairs. And here upstairs we continue with Wagner on Open API, and myself, I will be in the room 2 for FNC component architecture. So
I think it's important to tell that the agenda on the website is different from this one, right?
So room 2 FNC, room upstairs is Open API. Okay? And so lunch should be ready now downstairs. Enjoy lunch. You can leave stuff here. We will close the door.